All right, hello everybody. We are doing the honors topic of multiplying matrices here. So the one big thing when you're multiplying matrices is that you want to multiply rows by columns. That being said, when I multiply my first row, I'll be multiplying corresponding terms in this row with corresponding terms in my first column. Then I multiply corresponding terms in my first row by corresponding terms in my second column. And you keep doing this with that first row until you get done with your very last column. In this case, I only have 2 columns, so I will only be doing that process twice. Then I would go on to my following row, which here would be row 2, and start that process over again. Row 2 by column 1, row 2 by column 2. And again, I would keep going for every row that I have and every column that I have corresponding with those. 2 big things that we have to do when we are multiplying matrices is we want to determine the dimensions of each. So this is a 2 by 2 and this is a 2 by 2. This makes it really easy for me to know whether or not it is actually 2 matrices that can be multiplied together. If the matrices can be multiplied, because keep in mind, there are matrices that cannot be multiplied together. If they can, it's because after writing those 2 dimensions, their middle terms are equal. So in this case, I have to have this term equal to this term. If they were not equal, I would not be able to multiply these 2 matrices together. Okay, so we want to double check for that first. Are these terms equal? Cha-ching, they're equal, so I can go ahead and multiply them. When I do multiply them, we're going to have new dimensions. Because of the fact that both of these matrices dimensions are the same, I'm actually going to have the same outcome come out of this. So you take the first term and the last term from the previous dimensions, and that would be your new dimensions. So 2 by 2. So 2 by 2 would be my new matrix. We will do one that's not quite the same so that we can go ahead and show you what that would look like though. So in this one, when I go ahead and multiply, we're going to first have this beginning matrix that has all the terms kind of waiting to actually be added together. So I'm going to move that over here a little bit. We'll break it up between the center line. So here's my new first one. So again, we go row by column. So first column and first row multiplied by the first column in my first term, my first column. So 2 times 3. Except we add that now with everything in that same row. So my next term in that row is a 0 times the second term in my column, 0 times 2. And that's going to be 1 term of this matrix. Everything in my first row by everything in my first column. Now I move on to the first row, second column. So 2 times 4, because first term times first term, plus second term, 0 times 1. Okay, and that is the end of my matrix because that's my last column. If I had a third, I'd keep going. Onto my second row and my first column. So 1 is my first term, 3 is my first term. So 1 times 3 plus everything is still in that first or second row, -1 times 2. Okay, that's the end of this row. So that's the end of that term. So now I move on to my last and final term. Second row, second column, 1 times 4 plus -1 times 1. Okay, and the very last thing that you would truthfully just do here is actually do those multiplications and add those terms together. So if we did so, we would have 6 plus 0, 8 plus 0, 3 plus -2, and 4 plus -1. So 6, 8, 1, and 3 would be my final 2 by 2 matrix. It's always good to check yourself in the very end to say, well, what kind of a matrix should I have gotten? I was supposed to get a 2 by 2 as my new dimensions. Well, look at that. I got a 2 by 2 for my new dimensions. Okay. Let me do a couple more with you guys. So all this work, I'm not incredibly forceful that you do this step. I think it's a good step to do especially when you're trying these out for that first time. If you jump from here to here, I will not be able to see if you made any mistakes. So if this answer is wrong, it's going to be really hard for me to go say, well, they knew what they were doing. They just multiplied 0 times 2 wrong, right? So this step is helpful for me to help you find your mistakes. If you jump to here, partial credit on these iron points, or like me being able to say, well, you just multiplied 2 numbers together wrong. I'm still going to give you the credit even though you got that wrong answer. It's going to be really hard for me to be able to say that and give you those points still if I don't see this step. So if you're so confident in yourself, go ahead. I really caution you to do this step though. Okay. Let's do another one. So we can do, let's see. Go, let's do this one. Oh, no, not that, not that. I'm gonna do this opposite. Actually, this is a really good thing to say. I am gonna do it this way. I apologize. Okay, so let's check this first. So let's call this matrix A and matrix B, and I want to find A times B. So the first thing I'm going to say is, this is a 3 by 1 matrix, and this is a 1 by 3. Okay, so in this matrix, I'm just going to first say, are you able to multiply these two things together? The answer would be yes, because my middle two terms are equal. Okay, 1 by 3 by 1, 1 by 3. 1, 1, those two terms are equal. Your new dimensions would be a 3 by 3. So because of the fact that there's only one row or one term in every row, you're not going to be adding any terms together in this one. Okay, so if we did actually multiply these out really quick, it would be 1 times 0, and then 1 times 1, 1 times 2. Okay, because there's nothing else in this row to multiply by, I have nothing to add on. Then I go down to my second row and say 2 times 0, 0, 2 times 1, 2, 2 times 2, 4. Again, nothing else in this row and nothing else in this column. So as soon as I'm done with this term, I'm on to my same row, next column, same row, next column. Then next row, column, same row, column, same row, new column, which makes this one a really weird one. Lastly, you have 3 times 0, 3 times 1, and 3 times 2. Okay, that's an odd case. So let's leave this one up. What if I asked you to multiply? This is what A times B equals. What if I asked you to multiply B times A? Would that give me the same result? Generally, when we're talking about multiplication of anything, it's going to be a communicative, meaning that we are able to flip-flop that and it's still going to be the same thing, okay? Think about the two numbers, 3 times 5. That equals 15. Think about the numbers 5 times 3. That also equals 15. Here, it follows through to be both directions. Both directions are going to work. No matter how you switch that up, multiplication will stay the same. Matrices, this is not true. So A times B does not equal B times A. Those two matrices will not be alike. They are very different multiplications. If I did take B times A, my B is a 1 by 3. My A is a 3 by 1. So I would be multiplying a 1 by 3 times a 3 by 1. So in this case, yes, they are still equal, so I can still multiply them, but I'm going to have a 1 by 1 as my new matrix, which seems super weird. Okay, super weird. But think about it, I only have one row, so this one row is multiplied by all these terms. Okay, let's work that out really quick. So we start with this one, right, because we were multiplying this the opposite way. So you're kind of thinking about it a different way, but first row, first term, 0 times 1 plus 1 times 2 plus 2 times 3. So 0 times 1 is 0, 1 times 2 is 2, 2 times 3 is 6. Add those up. 8 would be your entire matrix there. Okay, really weird stuff here. Okay, a little bit different than stuff that you're working with, that you're used to working with. When you think about adding, subtracting, or multiplying matrices by a scalar, incredibly straightforward. When you would think about multiplying two matrices together, you would think like, oh, it's still going to be just as straightforward. Totally different style of doing this and totally different technique. If you want to hang around for one more, I will do one more quick one. I can do one more quick one. Let's do a 3 by 2 and a 2 by 3. Yeah, let's do that. Okay. Just keeping the numbers small just for the sake of showing you how to do this. Okay. So now going through this exact same thing, let me do it down here. We're going to take A times B. So middle terms are equal. Ching, we can do this. Our new matrix will be a 3 by 3. So let's kind of move us over here a little bit. Multiplying these two out. Again, you have to start with your first row, first column. So we start off first two terms, 0 times 1 plus 1 times 0. Okay, that's my first term of my 3 by 3. So that's my first row, first column. I still need my next two columns and my next two rows to fill in. Now we go on first row, second column. So 0 times 2 plus 1 times 3. Second term, first row. There we go. Very lastly, first row, third column. 0 times -1 plus 1 times 5. There's the end of that matrix. Second row, first column. 2 times 1 plus -2 times 0. First term. Okay, moving on to the next term. First row, second column, 2, 2 plus -2, 3. That's for that row and that column. Still second row, third column, 2, -1 plus -2, 5. All right. Very last row, we still need to go through column 1, 2, and 3 for first term, second term, third term. 1 times 4 plus 4 times 0. 1 times 1 plus 4 times 0. Okay, first row, second column, or third row, second column, 1 times 2 plus 4 times 3. And very lastly, third row, third column, 1 times -1 plus 4 times 5. Okay, Very last thing you would do here, and I'm not gonna keep you waiting any longer, to finish off this video, is you would multiply these out, add up those terms, give me that very last matrix there, okay? If you have any questions on this, please let me know.